You have previously learned about photosynthesis and cell respiration, and you probably figured out early on that molecules like oxygen and carbon dioxide and water and glucose are recycled. The products of one reaction become the reactants of the other. Photosynthesis and respiration are just two processes involved in biogeochemical cycling, which is the focus of this video lecture. We know that bio means life, and you might already know that geo refers to rocks. So the term biogeochemical cycle indicates that matter is being cycled throughout different components of the earth, both the living and the non-living. Remember that the law of conservation of matter states that matter cannot be created or destroyed, but rather it's transformed. As we learn about biogeochemical cycles, you will see how matter is transformed by many different processes. Because matter is recycled, we could, in fact, be drinking the same water and breathing the same air as the dinosaurs once did. There are many types of biogeochemical cycles, but in this video, we'll focus on 4 of the major ones: the water, carbon, nitrogen, and phosphorus cycles. In order to understand biogeochemical cycles, it's important to recognize that Earth can be thought of as having 4 spheres. There's the atmosphere, which is the gaseous portion of the Earth, or the air, the hydrosphere, which is the water portion, the geosphere, which is the rocky portion and also includes soil, and finally the biosphere, which is the living portion of the Earth, and of course where we spend most of our attention in biology. In biogeochemical cycles, matter is going to move between these 4 spheres and is in many cases transformed along the way. Listed here are a few terms that you will see in several of the cycles that you might not be familiar with at this point in time. First, fixation refers to the conversion of inorganic compounds into ones that are more useful for organisms. Uptake refers to the absorption of matter by plants. When animals eat those plants, then they have access to that matter. Finally, decomposition, which is normally done by organisms like bacteria and fungi, breaks down organic matter from either waste or from dead organisms and returns the nutrients to the soil so that they can ultimately be recycled. The first cycle we'll go over is the water cycle, and this is because you've probably already had some exposure to this. The water cycle contains many different processes, but there are 4 major ones listed here. First, evaporation refers to heat changing water from a liquid into a gas. You've experienced evaporation firsthand if you've ever put a pot of water on the stove and watched steam come off of it as the water boiled. The heat from your burner was able to change the water from a liquid into a gas. Transpiration is like evaporation, but it's from the leaves of plants. Basically, plants are losing water through their leaves to evaporation. A student once described this as plant sweating, which I think is a really good way to think about it. Next, condensation is the process by which water cools and transforms from a gas into a liquid. Water needs surfaces in order to condense. For example, up in the sky, particulates are tiny particles provide surfaces for water to condense on up in the atmosphere, and this is how clouds form. On the ground, grass can provide a surface for water to condense on, and that results in dewdrops. So if you've ever walked outside in the morning and got your shoes wet, there you go, that's condensation. Even a window pane can provide surfaces for water to condense on. This is why when you breathe on a window, it will fog up. The final major process is precipitation, where water falls from the sky back down to the earth as rain, snow, sleet, or hail. Pictured here is a schematic of the water cycle, and you can see there are many processes involved, but you really just need to pay attention to the 4 on the previous slide. Over here we see evaporation, where liquid water, after becoming heated, will turn into water vapor and rise up into the atmosphere. Right next door, you see the term evapotranspiration, and that's another way of saying transpiration, where water evaporates through the leaves of plants. In either case, water vapor goes up into the atmosphere and will cool off and begin to condense and form clouds. When those clouds become too heavy and the conditions are right, water will fall back down to earth as precipitation, rain, sleet, snow, or hail. Once the water has fallen back down to earth, there are a variety of things that could happen to it. For example, the water could soak into the ground and become groundwater. It could run off over the surface of the land and enter lakes and streams and things like that. It could even freeze and become ice. If you're interested in learning about the complex nature of the water cycle, I encourage you to take Earth or environmental science. Next is the carbon cycle. We've learned about photosynthesis and respiration, and these happen to be two processes involved in the cycling of carbon. For most of the time, carbon is going to move between the living and non-living things in the form of carbon dioxide. We know that in photosynthesis, plants will absorb carbon dioxide from the atmosphere as a needed reactant for photosynthesis. And then both plants and animals will give off carbon dioxide as a byproduct of cell respiration. And in that case, the carbon dioxide would be released back into the air. Photosynthesis can actually be thought of as a form of carbon fixation. Carbon dioxide in the atmosphere is an inorganic form of carbon, not really able to be used by many organisms for life processes. So during photosynthesis, plants convert or fix that carbon into glucose. And that's a much more usable molecule for living things because it can be broken down for energy. Whether it be plants or animals or any other kind of organism, when living things excrete waste or die, that organic matter is broken down by bacteria or fungi through decomposition. And that's going to return some of the carbon-based molecules back to the soil where they can be recycled. In addition, those decomposing organisms also perform cell respiration. And we know that that results in carbon dioxide being released to the atmosphere. If instead of being decomposed right away, the organic material gets buried, over the course of thousands or millions of years, that material will be transformed into fossil fuels like coal, oil, or natural gas, as you can see down here. When humans burn those fossil fuels for use as a non-renewable energy source, that combustion is going to release carbon dioxide up into the atmosphere. So as you can see, there's a lot more complexity to this cycle than you really need to know for this course, but just understand that photosynthesis is going to take carbon dioxide from the atmosphere and store or sequester that carbon during the formation of glucose. Respiration and combustion then will release that carbon dioxide back into the atmosphere. As humans continue to burn fossil fuels, more carbon dioxide is being released into the atmosphere than can possibly be absorbed by plants. This is going to create an imbalance of more carbon dioxide in the atmosphere than in other areas, and you might know already that that contributes to climate change. Nitrogen is an essential element needed by organisms for amino acids, proteins, and nucleic acids, which you should remember from the macromolecules chapter. The air is made up of about 78% nitrogen gas, so it should be pretty easy for us to get the nitrogen we need, right? Not quite. N2 gas, up in the atmosphere, is an inorganic form of nitrogen that's not very useful to organisms. So in order to be able to use nitrogen to build those macromolecules, the nitrogen gas must first be converted to more usable forms through nitrogen fixation. Most nitrogen fixation is performed by bacteria, although lightning can actually fix nitrogen too. These bacteria live in the soil or in aquatic ecosystems. In either case, they're going to be able to convert that nitrogen gas into nitrates and nitrites, which are more usable forms of nitrogen that plants can uptake. When animals eat those plants, then they get their nitrogen. Decomposition then can return nitrogen compounds to the soil or aquatic ecosystems. In order to get nitrogen back into the atmosphere and finish the cycle, a different group of bacteria will convert those nitrogenous compounds back to N2 gas through a process called denitrification. There is a lot more complexity to this cycle than what's covered in the class, but this is really what you need to know at this point in time. I like to think that bacteria sort of run the nitrogen cycle, in the sense that without them, other organisms would not have access to usable nitrogen, and nitrogen would not be able to return back to the atmosphere. The final biogeochemical cycle for this lecture is the phosphorus cycle. Phosphorus is needed for our nucleic acids. What's unique about this cycle is that there is no atmospheric phase. Many rocks contain phosphorus. When these rocks are weathered, soils form that contain phosphates. These phosphates are then uptaken by plants and then transferred to the animals that eat them. Finally, decomposition returns phosphates back to the soil to repeat the cycle. This concludes this video lecture on biogeochemical cycles. Should you have any questions, please ask the teacher. Thanks for watching.